Imagine a place where gravity is so strong that if you got too close, you could never leave. Not your spaceship, not a beam of light, not even time itself behaves the way you'd expect. This isn't science fiction. It's one of the most extreme objects in our universe, and it's hiding at the center of nearly every galaxy. So what is actually inside a black hole? First, a surprise. A black hole isn't a hole, and it isn't really an object you could touch. It's a region of space where so much mass is packed into so small a space that gravity overwhelms everything. Think of it less like a thing and more like a one-way door in the fabric of the cosmos. In 2019, humanity did something astonishing. Using a network of telescopes spanning the entire planet, scientists captured the first real image of a black hole. This glowing orange ring sits in galaxy M87, 55 million light-years away. That dark center is the black hole's shadow, and the ring is superheated gas swirling around it. 3 years later came an even closer subject, the supermassive black hole at the heart of our own Milky Way. It's called Sagittarius A star, and it weighs about 4 million times more than our Sun. Despite that, it's so far away that photographing it was like spotting a donut on the moon. Now let's travel inward. The boundary of a black hole has a name, the event horizon. It's not a solid surface. It's an invisible line in space marking the point of no return. Cross it and there is no escape because escaping would require traveling faster than light, and nothing can do that. Here's why light itself gets trapped. Gravity, as Einstein showed, isn't really a force pulling on things. It's a curving of space and time. Near a black hole, that curve becomes so steep that every possible path, even a beam of light, bends back inward. Light doesn't get pulled in so much as it simply runs out of directions that lead out. This is also why a black hole looks black. Normally, we see things because light bounces off them and reaches our eyes, but a black hole gives off no light and reflects none. Anything that falls and stops sending us any signal at all. We only see black holes by what swirls and glows around them. So what would happen if you fell in? It would not be gentle. Because gravity gets dramatically stronger the closer you get, your feet would be pulled far harder than your head. You'd be stretched, thinner and longer like a piece of pasta. Physicists actually have a name for this, and it's wonderfully silly. It's called spaghettification. The difference in gravity between your head and feet would stretch you into a long, thin strand. For a small black hole, this would happen before you even reach the edge. For a giant one, you could cross the event horizon intact and only later meet your noodly fate. And time, it gets strange too. To a friend watching from far away, your fall would appear to slow down as you approach the horizon. You'd seem to freeze and fade, hovering forever at the edge. But from your own point of view, you'd sail right through, no pause at all. Both versions are true. Now we reach the heart of the mystery, the very center. Einstein's equations predict that all the mass collapses to a single point of infinite density, called the singularity, a place where space and time, as we understand them, seem to simply break down. It's the deepest question in the whole story. But here's the honest truth. When physicists' equations spit out the word infinity, it usually means the theory has hit its limit. Most scientists don't believe there's a literal point of infinite density. They believe it's a sign that we're missing something. We simply don't yet know what truly sits at the center. The problem is that we have two brilliant theories of physics. General relativity describes huge things like gravity and galaxies. Quantum mechanics describes the tiniest particles. Inside a black hole, the huge and the tiny collide and the two theories disagree. To understand the center, we'd need a theory that unites them, one we don't have yet. There's another twist. The brilliant physicist Stephen Hawking realized black holes aren't perfectly black after all. They slowly leak a faint glow, now called Hawking radiation. Over unimaginable stretches of time, far longer than the current age of the universe, a black hole could actually evaporate away to nothing. Black holes come in sizes that boggle the mind. The smallest, born when massive stars collapse, are only a few times heavier than the Sun. The largest, lurking in galaxy centers, can weigh billions of suns. Our own galaxy's giant, Sagittarius A star, helps hold the entire Milky Way together. Far from being cosmic vacuum cleaners that suck up everything, black holes mostly sit quietly, only pulling in matter that wanders too close. If our Sun magically became a black hole of the same mass, Earth wouldn't get swallowed. We'd keep orbiting exactly as we do now, just in the cold and dark. So what's inside a black hole? Past the event horizon lies a region where light can't escape and time bends. And at the very center, our best science honestly runs out. The singularity is less an answer than the universe's way of telling us our theories aren't finished yet. And maybe that's the most wonderful part. Inside these dark giants sits one of the greatest unanswered questions in all of science, waiting for someone, perhaps someone watching right now, to help solve it. If this sparked your curiosity, stick around. At The Curious Owl, there's always more wonder, one bite at a time.